Hello and welcome to my video about wave basics, or the basics of waves. We're talking about physics 20 here, and we have a few formulas to look at this lesson, and then we have a whole bunch of vocab that we need to know, and then we'll talk about some of the actual parts of a wave and types of waves and that sort of thing. Okay, so first of all, here are two equations that we have. We've got the period is this part is equal to 1 over frequency, or the other way around is true as well, that frequency equals 1 over the period. Frequency is measured in hertz. Hertz, like this. And that's more useful than the period actually is. So we normally use frequency when we're talking about waves. Because frequency is used in this formula. This is the speed of a wave, the velocity of a wave, equals the wavelength times the frequency. So the speed is actually a constant, and the wavelength and frequency are the things that will change. If one goes up, the other goes down. If one goes down, the other one goes up. So we have two different kind of types of waves. We've got curved waves like this, or straight waves, and the direction of propagation is, can go whatever direction the wave is moving. Okay, so we've got a bunch of different vocabulary here. You can see them all here, but I'm going to go through them one at a time. You can skip ahead if you need to. Source is whatever's creating the wave. So if it is, sound wave, my voice, or the speaker in your phone right now, the speaker is the source. Or in the room that I'm in, my voice is the source. The medium is the material through which it's propagating. So propagating just means traveling through. So it's whatever the material is. So this is air in the case of a sound wave, water in the case of a water wave, whatever wave you have is traveling through something. Okay, the propagation is a way of talking about the movement of a wave through a medium. So it's just when you talk about a wave propagating, it's just the movement of the wave, whatever that is. So these are kind of interesting and or important words that you have to know about. But here, these bolded ones are the most important. So frequency is the speed at which the wave pulses. So basically when the wave goes up and down, whoops, that was not very good, up and down, up and down, up and down, that pulsating, that tempo, however fast these beats come, that is the frequency. Okay? The speed of the wave is how fast the wavefront moves across the room, or across the spring, or a rope, or across the screen, or whatever it is. So how fast does the wavefront actually move? So frequency is how fast does it go up and down from peak to trough. Speed is how fast does it move across the screen. So that's moving faster because it's gotten across the screen faster. This is actually has a very low speed. It has a high frequency but a low speed. This other one here has a low frequency but a high speed. Okay. Wavelength is a measurement or distance from peak to peak or trough to trough. So whatever that possibly is, we'll look at an example down below. Amplitude is the distance between the maximum and the equilibrium, or more commonly found as the max and min divided by 2. And the equilibrium is like the middle of the wave, so that's why both of those equations kind of work at the same time. So it's the middle. The wavefront is the part of the wave that's moving through, so this is the energy transfer that's happening through a medium. Mechanical waves are transverse or longitudinal, and these waves are physical and you can see them move. Electromagnetic waves are waves that travel through the universe like radiation or light. Okay. And we're going to focus on mechanical waves. So we'll mention electromagnetic waves, but that's going to be a side comment to what we're talking about. And then sound waves are also kind of a form of mechanical waves, but it's a specific type where it's a compression in fluid allowing for sound. And that's often in air, but it doesn't have to be, and we'll look at some examples of that later. Okay, here's the first kind of actual piece of knowledge other than definitions. The law of reflection. Whatever the angle is coming in equals the angle out. So those two angles there are equal. Okay, and this is something we'll learn in grade 8 science. Angle in equals angle out. Okay, types of waves. So we've got transverse waves, which move up and down. You've got kind of a picture here that kind of shows that, but basically waves that go like this. Compression waves are ones that move in and out, kind of like sound waves. So I have those right here via images or GIFs. So you can see the top one there is a transverse wave. It's moving, the particle motion is perpendicular to the energy transport. So the particle motion is up and down while the energy transport is side to side. Longitudinal, the particle motion is the same direction as the energy transport. Okay, so yeah, those are the two types of waves, and they act in most ways the same, but in some ways slightly differently. So parts of the wave. So it's easier to see in a transverse wave and to define it in a transverse wave, but it is true for both types of waves, longitudinal and transverse. So I'm going to draw this for a transverse wave. This would be our equilibrium point, kind of in the middle of the wave. Okay, and the amplitude is going from whatever that middle point is to the peak, or from the trough to the middle point. So this is the amplitude. Okay, so if that's the amplitude, what about the wavelength? So the wavelength is from peak to peak, or from trough to trough. And yeah, these are not perfect, but that's the wavelength. I didn't draw it perfectly, but they should always be the same from peak to peak or trough to trough, or from midpoint to sorry, I did that wrong. Midpoint going up to midpoint going up should also be the same. Just interesting to note. There you go, and there you go. Okay, so what else do we have? The crest is up here, which I'll often call peak. And this is the trough down here, or sometimes called the valley. Okay, the frequency, whoops, I wanted a different color there. There you go. The frequency is how fast does it go up and down, which really we cannot draw here. So we're just going to say how fast does it go up and down. So this does need an amount of time, but basically if you think about one period, it would be one wavelength. So from there to there, right? And so we have one wavelength, one period, but then you need to go 1 over the period is the frequency. Okay, so it's not exactly what I did, it's how fast is it doing that. Okay, so now what about the wave velocity? So we're going to actually scroll down a little bit so we can see this next GIF. So it's the wave velocity, like I said before, is set by the medium and will be constant throughout. So different mediums will have different wave velocities. So if you look at these, you can see a solid has the particles packed closer together, liquid in the middle, and then gas has them more spread out. And based off of this, generally speaking, this rule is true. Which one's faster? Well, solids are faster. So the velocity in a solid is faster than in a liquid or a gas. And you can see kind of why, if you stare at this GIF long enough, you can hopefully see why the solid is faster. It's because the tips are hitting the next particle faster. And so every single one goes quicker and quicker and quicker, and so it'll reach the end faster. So it's actually moving faster. Okay, so solid, liquid, gas, and then different types of chemicals or substances will have different velocities as well. So if the velocity is constant, we will have the following formula. There's the formula. Therefore, frequency will increase as wavelength decreases and vice versa. So velocity is constant, as we just discussed. It depends on the medium, but other than that, it's constant throughout the same medium. And so if you have a higher frequency, then you'll have a smaller wavelength, because velocity has to be constant. So that doesn't change. So it's the wavelength and frequency that changes. So smaller frequency means bigger wavelength. So that's what those two are showing there. And it comes down to this formula. So velocity is constant. So that means if this goes up, this goes down, because they're multiplying. So they're exactly inversely proportional. And if this goes down, then this goes up. And that'd be frequency and lambda. Lambda is our symbol for wavelength. This is a Greek symbol. I don't know why we use that one, but it's the one we use for wavelength. All right, so we have a few questions here. So I would recommend pausing the video at this point and trying them yourself, see if you can get them, and then otherwise we're going to do them together. Okay, so if the speed of sound in a dry room at room temperature is 343 meters per second, then the middle C note on a piano, which is that many hertz, what is the wavelength? Well, velocity equals frequency times wavelength. So if we're looking for the wavelength, we just divide by F, and so wavelength equals velocity over frequency, which is 343 over, and this is meters per second, over 216.63 hertz. And so it's going to tell you the answer in meters. So that would be this calculator here. My other calculator is not working at the current moment, so I'm just using this one. 343 divided by 216.63. Simple enough. So 1.58 meters. And just in terms of sig digs, yes, we should have 3 sig digs because of this. Okay, let's try the next one. We've got, given the speed of sound in water is about that, and the frequency of sound is that, or what is the frequency if the wavelength is that? I said it twice here, which is kind of funny. There you go. That's a better question. Okay, so we're going to use the same formula as before, but we're going to divide by, we want to find frequency, so we're going to divide by the wavelength on both sides. So that means frequency equals velocity over wavelength. So 1,500 meters per second over the wavelength of 88 meters, which means that our answer is going to be 1 over seconds or hertz. So 1,500 divided by 88, which is 17, well, we'll just leave it there, 17 per second or hertz. Okay, here's another very simple question. So example number 3, and then you can also try example number 4 afterwards. Number 3 is basically the same question again. So velocity equals frequency times lambda. We're looking for the wavelength, so we're going to divide by frequency on both sides. And so we're going to be left with lambda equals velocity over frequency, which is 343 meters per second over 20 hertz. So this is going to be our one answer, but we're going to have to do that again for 20 kilohertz. Which is going to be 20, and then if it's kilohertz, you times it by 1,000 to get the actual hertz. And so that's why, this question might be slightly more challenging than before. We have to do it twice. Divided by 20. So it's 17 meters on the one end, but on the other end it'll be divided by 20,000 0.017 meters, which is really 1.7 centimeters. Yeah, that would be correct. Okay, so to give you some idea, humans can hear things from about 17 meter long wavelengths all the way to 1.7 centimeter wavelengths. Okay, and that's a healthy, young human. As you get older, you kind of lose range on both sides, but mostly on the high end. All right, so we're going to do this question here. So we're going to, first of all, notice that angle in is angle out. So this is going to be a 65-degree angle because it started 65. Then what we're going to do is we're going to figure out the red angle. So 90 minus 65 is going to give us 25 degrees. So that's going to be this angle in here. Now we have to remember that to get the purple angle, that every triangle adds up to 180. So 180 minus 20 minus 25 equals, and so we'll have 35 degrees as our angle for purple. Then to find the other angle beside the purple, it's going to be 90 minus 35, 55 degrees. So this is a 55, and since that's 55, angle in is angle out, this is also going to be 55. And so our final answer is 55 degrees. Okay, so I hope this video helped you understand the basics of waves, different definitions, as well as the types of waves, parts of a wave, angle of reflection. Hope this video helped, and good luck.